morning and welcome to the CABE webinar Wednesday. Today we're looking at mitigating ground heave, ground gases and contaminants, providing lightweight fill with Simon Robert. The CPD gives an overview of challenges associated with ground heave, ground gases and introduces lightweight EPS fill for varied void forming project applications. My name is Shanika and I'm the Training and Learning Administrator here at CABE. I'll be acting as moderator for this morning's session. We like to make our webinars interactive, so we do encourage you throughout the session to send in any questions as we go along, which we will address at the end of the presentation. If you are watching us live, you can use the side panel to send in your questions. Alternatively, you can get in touch with us via the social links now on screen. Let me introduce today's webinar speaker, Simon Roberts. Simon has been employed by Cordec for over 10 years as a technical advisor on standard engineered sector products. Simon has recently expanded his sphere of knowledge to include bespoke formwork applications for infrastructure and superstructure formwork. Prior to working at Cordec, Simon was involved in the formwork and falsework industry. So if you give me a couple of seconds, I'll just hand over to Simon and he will begin shortly. Right, Simon, I have stopped sharing. You can now share your screen. So I can see.
Right, let's just see if we can get this. There we go. Right, by the wonders of technology, thank you very much indeed. Thank you, Shanika. Welcome, everybody. I'm going to be running through what is essentially our Cordec Solutions CPD, and this does cover the three main topics, which are problems associated with ground movement, so expansive clay soils and others, and also looking at problems associated with contaminated land, gases, hydrocarbons, that sort of things, and finally rounding off the webinar with a little overview on what we can achieve using our structural fill products, our expanded polystyrene fill products within certain applications that we might find within the industry. Okay, so here we go. Right. Hopefully these slides are moving at a reasonable pace in line with what I'm saying. So we are going to be covering ground heave solutions today, VOC and ground gas protection and structural fill. The company does have a range of other products that you can see here as the slides are scrolling through. Cordec as a company, we are a manufacturing company based in West Sussex. We are predominantly involved in the construction industry. However, we do provide solutions for various different other markets such as landscaping, rail, highways, television and film, marine, where you might have the need to introduce either a polystyrene product to satisfy a particular solution or offer a gas protection system, again within that project scope. So the webinar itself is broken down into various different categories. So we're going to start off by looking through the ground movement section. Right, let's put up both of these slides. So you can see there on the left-hand slide, the residential example. There is a crack extending up through the external envelope of the building, through the brickwork there, and that crack has been caused by a potential volume change from the strata below, which has caused an upward force to be exerted through either the edge of the slab or the ground beam or the pile cap, and has caused that cracking in the external envelope of the building. We can also experience compression of surfaces underneath the footprint of the building. That's something else that is caused by heave. So in that particular example, the heave may have occurred as a result of a potential volume change from either an expansive clay soil, which is probably the most common cause of heave. We also have an example where we can consider heave from a byproduct of the mining industry, so reconstituted slag. That will behave in a similar sort of way as to what an expansive clay soil will in terms of expansion and contraction through desiccation and hydration. There is also the permafrost example where we have perhaps a layer of strata that is permanently frozen. We have a change of use. We then start experiencing the freezing and thawing cycle in that particular example. And again, we're coming back to what a clay soil might do in comparison with the freezing and thawing cycle produced by the permafrost situation. The right-hand example there is an example of a commercial project that we were involved in. That is Moorgate Shaft, which is on the Crossrail line. It's a very deep excavation, between 40 and 60 meters deep. It's an example of overburden recovery. So that is where we are removing a mass bulk of soil. And when we do that, we are relieving pressure at the base of that particular shaft, and we're starting to experience a potential volume change even at that depth. It was quite an interesting project because we had to accommodate for quite a lot of movement at that depth. So there was a 400 millimeter deep panel that was introduced. More commonly, you would experience something like that if you had a basement situation, if you were constructing a basement, again, removing a mass bulk of soil, overburden recovery situation. That is going to be more prevalent, I would say, in some of the major cities, certainly in the London area, where there's a lot of basement construction going on, spaces at a premium. So basically, residential example caused by an expansive clay soil, or a reconstituted slag, or a permafrost situation. The commercial example, an example of overburden recovery, removing that mass bulk of soil and relieving pressure from that particular area of the excavation. So we work with several warranty providers. The NHBC has been probably the longest standing company that we've been associated with. We certainly adopt some of their guidance that is generated in chapter 4.2, building near trees and expansive clay soils, and we put that into our data sheets and our tables when we're actually offering specifications for our particular ground movement range of products. The NHBC produce technical extra and technical standards. This particular publication just looked at the financial impact of heave-related claims. Common causes of heave-related damage was something that was of interest. Incorrect foundation depth, that can be remedied by selecting the appropriate foundation from perhaps 4.4, building in expansive clay soils. Lack of heave protection, that is where heave protection is specified and not put in. And obviously we revert back to the issues that we saw in the previous slide through the cracking of the actual external envelope of the building. Or poorly installed heave protection, that is where Cordec can assist in the provision of data sheets, standard details, BBA certification, and certainly visiting clients on site and giving site advice as to the correct way to install a heave product. We do work with other warranty providers such as Premier, Akidis. There are others that have come on the marketplace sort of post NHBC, and as I say, the guidance is pretty much the same through all of their offerings. So how do we actually know if we've got heave? Well, evaluating your site is always a good start. I would always recommend, where reasonably practicable, that you investigate your site and get a proper SI report done. In so many cases, usually domestic examples, the site investigation isn't undertaken. So in that particular example, we would have to advise on a worst case scenario, so a very highly shrinkable clay soil. So we would advise to install products to take care of that particular scenario. So evaluating our site, right, so we go to site, we identify the soil strata that is there, so what is physically there. From that we then get the characteristics of how that soil behaves. From that we then get the plasticity index and the heave potential. And it is the plasticity index and the heave potential that we consider when we are specifying the depth of a compressible polystyrene void former. Now, this particular operation can be done by either a specialist geotechnical site investigation company, that's perhaps a standalone company, or one that is in-house as part of one of the larger structural engineering consultancies. Perhaps that's a little sort of division, the geotechnics guys, headed up by the overarching structural guys, can go out and provide that particular service. If you can't have that particular service undertaken and you want to refer to the NHBC or the local building control or local authority, they will all have historical geological information for a particular geographical area where you're looking to introduce your project. Worst case scenario still is you can always consult the geology map of the United Kingdom, and that will tell you where the expansive clay soils occur. So industry guidance documents, obviously we've got building regs, we've got chapter 4.2, building near trees and expansive soils. It is an NHBC document. I'm sure we're all fairly familiar with it. We also have the NHBC free app. I don't know how free it is, but it's certainly free to download it onto your particular smartphone or iPad or Surface Pro or whatever hardware you're using. It's a pretty good guide going from everything from the foundation up to the roof. Fairly interactive. I've heard mixed reviews about it, but generally good. So those are the guidance documents that are out there. So how does the industry view the issue of ground movement, and how do they deal with it in an industry-wide sort of a situation? So you can actually remove the expansive soil on your particular site. There's obviously lots of pluses and minuses with this. The pluses are if you can actually just shift it around, so you can take it away from the footprint of the building that you're going to introduce and use that expansive soil on site as part of the landscaping solution, then it's not too bad a thing to do. Obviously, if you're removing an expansive soil down to a particular depth, you have to re-import with made ground. There is a cost element involved to it. It has been done both times in Milton Keynes. Does it get rid of the problem? Not entirely. Made ground will still tend to heave, although it may reduce the actual impact of the heave in terms of moving it from a high potential volume change to a medium or a medium to a low. The other solution that you could consider would be lime stabilization, soil stabilization. So that would be basically excuse me, I'll just move this out of the way. It's just basically introducing lime sulfates into the actual mix of the strata. So you're modifying the characteristics of how that strata behaves. Obviously, lime stabilization, you can see there we've got a lot of equipment on site. So we've got tractors, we've got machinery, we've got site personnel. You have to modify the whole site and not just the footprint of the building that you're looking to introduce. You also have to do post monitoring to ensure that the process that you've undertaken has worked and is continuing to work. It does, on the plus side, alleviate the need for piling. But if we're looking at a piled and ring beam foundation situation or a piled raft situation, we're very specific in an area that we're looking to introduce a structure onto a particular site. So obviously we don't have to deal with modifying the characteristics of any soils over the whole site. So as I say, pluses and minuses with both arguments on that. More so what we're looking at doing is introducing a void underneath a pile cap, a ground beam, or a slab. The left-hand example here that you can see, so this is your block and beam floor. This is where you have a simplistic voided area underneath your block and beam slab. So if the ground does actually heave, then you get that expansion of the strata underneath your slabbed area, and it's got a voided area, so it's got somewhere to move into. Normally that would be considered in housing application. We would still have to consider at the perimeter the foundation type around there, accommodating lateral movement for any classifications higher than a low. So if you have a medium potential volume change, a high potential volume change, or an extra high potential volume change soil, you would have to accommodate lateral movement. Moving on to the right-hand side, so this is our heave protection product that we're actually looking at talking about this morning. So this is a compressible polystyrene void former. The thing about compressible or collapsible polystyrene void formers is that they have to be used in conjunction with a cast in situ suspended slab, and that's tied into either a piled and ring beam foundation situation or a piled raft. It's not suitable for ground bearing slabs. The reason for that, we have this constant up here, which is our concrete. That has to be tied into something to offer resistance, so that when the expansive clay soil increases in size underneath the footprint of our building, it generates an upward force, and that compresses the cellular legs. We have to have a constant there tied into a perimeter so that we can resist that expansive force from the strata below to get those legs to progressively collapse. Okay, there are various different types of polystyrene void former for various different applications, and we will look through those moving forward. In terms of providing a polystyrene void former, we are basically introducing that to protect the concrete whilst it goes off and maintains full strength. Once that concrete has gone off and maintained full strength, we are actually almost having a redundant type of formwork product underneath there, because the slab, or the beam in engineering terms, is spanning, and then that is working to accommodate any subsequent heave. You've got that voided area underneath your beam or your pile cap or your slab. Okay, so compressible void formers, Cellcore HX. This is what we are talking about. This is a range of void formers that will take you up to 900 millimeters head of concrete. So it's a 4th generation void former, 25 years in development, and it carries the full BBA certificate. And there are 3 main products within the actual product grouping. So this one here is Cellcore HXS. The S gives you the clue that it's for use underneath floor slabs. It's for horizontal installation. It comes in an 8x4 sheet, or 1.2 by 2.4 in new money. And we always suggest that any of the Cellcore products should be installed on a blinding layer. You can see an example here of concrete as the blinding layer. There are also other mediums such as lean mix concrete, sharp sand and cement, sharp sand, or 10mm pea shingle. We like to see a flat level surface, flat to minimize wastage of concrete pour from the formation of the slab above. We like to see the blinding layer compacted so that we're not having the blinding medium going up into the actual cellular legs underneath and detracting from the performance of the product when heave occurs. And we like to install a blinding layer so that we negate any large aggregate that's on the surface that might come into the contact with the product and prematurely break the legs off the bottom of the product prior to the slab even being formed. As I say, this one is HXS. It's a standard product. So we have a collection of molded cellular legs. We have a 10mm polypropylene top, which is strong enough for you to walk on, and it has no insulation value for the actual thermal performance of the slab, as it is the standard product. If you wish to have Thermal performance to provide an insulative value from an anti-heave product. We would propose the Cellcore HX Plus product, which is a combination product. It gives you the insulated top and the cellular leg, so it is all glued together, so it is two products in one placement. So basically we're accommodating ground movement, and we're also providing some sort of thermal performance to go towards the thermal performance of our slab or our building. We do offer a U-value calculation service. Please do get in touch for that. We would need to know several simple bits of information. So what's the target thermal performance figure of either your building or your slab? What's the thickness of the slab, the exposed perimeter in the area, and the potential volume change of the soil below. And from that, we can come up with a U-value calculation for you, which we can email to you, and you can then share that with your client within the documentation. The last product that you can see there on the Cellcore range is Cellcore HXB. So that will come in a 2.4 meter length, and that's manufactured to beam width. It has a 5mm polypropylene board on top of it, which is different to the 10mm one for the slab. The reason we have a 5 on it is because we're not anticipating anybody walking on the product. It's usually for installation in trenches or formation of pile caps. We do manufacture to beam width, because you can see here the edge fins coincide with the edge of the actual panel. Many years ago, we used to manufacture it in 8x4 sheets and then send it out to the market, and the contractors could cut the panels down themselves to suit particular beam widths that they were looking to introduce. This had issues because obviously manual cutting is not as accurate as factory moulding and machine cutting. So we always manufacture to beam width. As an overview, when you have these types of tops on the actual Cellcore panels, if you're looking to introduce formwork, we can do that in a variety of ways. One of the ways that we would do it is to actually introduce some formwork tape at the corner joint there where loose laid formwork would meet it. The same can be said if you are not having a DPM placed on top of Cellcore panels under a slab. You should tape the joints where the panels abut each other to stop the ingress of concrete slurry weeping down into this particular area here and affecting the production of your void after heave. We also have a range of anti-heave products for lateral movements. This is our Heave Guard sheeting here. This is very similar to the Claymaster product that you may be familiar with. Basically, this goes down the inside face of the perimeter of the footprint of the building only. It is to accommodate lateral movement from an expansive soil, and we always colour it a pretty green colour. There are other colours available in the market, pinks and yellows and blues and what have you, but you should always have a coloured product down the side of a foundation. The reason for that is it's manufactured in a different way to white polystyrene. It will accommodate a far greater range of compressive strengths and movement. So, for example, it will start compressing at 1 kilonewton per square meter. You won't see significant compression until 20 kilonewtons per square meter, and the product will be fully compressed at 40 kilonewtons per square meter. If you, for example, put white polystyrene down the side of a foundation, we work on a 1% compression figure. And if, let's say, it's 50 millimeters thick, under a given load, it compresses by 1% of 50 mil and then transfers the load into the foundation. So hence, we always suggest the use of Heave Guard down the inside face of the perimeter foundation of your footprint of your building. We also manufacture the Heave Guard pile collars out of it. Gives you a nice square interface between the Cellcore that runs in from your beams to your pile caps, and also allows you to accommodate proprietary formwork on top of that if you're doing a formwork system. There are several different formwork systems that we can offer. This is Cellform, so we call this Cellform HX. It uses an 8mm twin fluted polypropylene board or plastic board. So we take the 5mm board off the actual, whoopsie-daisy. We take the 5mm board, sorry about that, off of the cellular product, the cell core below, and introduce the 8mm formwork on top of it. So it comes as part of a system. It has all of the straight line connectors, internal corner pieces, external corner pieces, heave guard, and pile collars associated with it as a system. So if your client wants a nice, quick, easy installation, we do all the work for them. So basically, we will tell you how many components make up a particular footprint of a building. It goes to site. Once the trenches have been dug to the correct dimensions, the product simply slots in. It is probably the most expensive way of doing it in terms of manufacturing, but the cheapest way of installing it in terms of labour and time saving. We can also offer formwork loosely supplied, so these sides can be loose supplied formwork. The cell core system does also lend itself to the steel type of formwork. So if you have your pecker fill that you want to put on top of there, or core grid, which is our version of it, you can do that. It is suitable to accept that. It's also acceptable just to accept something as simple as timber ply shuttering to produce your formwork. Right, how does cell core work? Let's hope this works, the animation on this. If not, I will be explaining it in two parts. Okay, so this is an example of our cell core under test down at our test facility at Slimfold. So we have testometric machines. What you will see is the top come down and squash the actual cell core. So the grade is 1824. So the first thing that we do is we actually put it on the test rig. So it sits there. We then add a bit of load onto the actual product, and that replicates creep compression. So that is what happens when site personnel walk over it, when they're laying out spacers and reinforcement prior to actually formation of the actual concrete slab above. So we apply the little bit of load, keep it on there over time. We then push the product up to its actual failure load and then beyond, and then the product actually compresses. And you can see there, that is our cellular legs compressed. So that's what heave looks like when heave occurs. You have a void that is full of compressed cellular legs mixed with spooled material. So basically what we've got there is 1824, safe working load of 18 kilonewtons per square metre, fully collapsed at 24 kilonewtons per square metre of upward force. So just how to specify, if we mentioned before about the plasticity index, we got that from our site investigation. All of these tables are on the website and also in the literature that we provide. So this will give you the plasticity index, the potential volume change as per the NHBC category, low, medium or high, the void dimension that's required, and the suitable products that we need to put in there. Every product has a grade, so we have two numbers on it. The first one is the safe working load in kilonewtons per square metre, which includes the live load allowance of 1.5 kilonewtons per square metre. The second one is the point at which the product is fully compressed or failed. So you can see there, for example, a 710 will take up to 220 millimetres of concrete. All of the products have little colours on them. So the reason we have little colours on them is just so that we can denote what product goes where, makes it easier for installation on site. So in our example, we're looking at a low potential volume change. So in terms of depth of product, we're looking at a 90mm deep product for under a slab. So that's how we select our depth, 90mm. HXS obviously denotes that we're going to be using it for a slab. The slab thickness is 220mm. We then do this little calculation, which is on the back of the data sheet and also on the website. We're coming out at a total load of 7 kilonewtons per square metre. So we would select the product, grade 710. So basically, at the end of it, you should come out with a full specification. Cell core, what it is, HXS, denoting it's for under slabs, 90mm for the depth and 710 for the grade. And it's fairly easy to track it back if there's parts of that specification missing. So in this particular example, we're looking at a ground beam, so 2.4 meter length, manufactured to beam width, medium potential volume change. So we're going to be selecting 155 mil depth of product. Our beam depth is going to be 600 mil. So again, we'll run the calculation through and come out with a total load of 16.5 kilonewtons per square meter. That falls somewhere in between. So we go up to the 1824. So we've got our safe working load of 18, fully compressed at 24 kilonewtons of upward force, and that will accommodate up to 660 millimeters head of concrete. So again, the final specification for it, cell core, what it is, the depth 155, HXB, denoting that it's for beams, so 2.4 meter length manufactured to beam widths, and finally the grade 1824. Okay, right. So that rounds up the first part of the presentation on ground movement. We're now going to look at just an overview really of ground gases. We do have another presentation that goes into more depth specifically on ground gases and contaminants. So how do they occur? So ground gases and VOCs can either occur naturally, so that's our greenfield sites. An example there, you can see the picture is perhaps a peat bog. So we've got degradation of vegetative material, and that in itself will produce something like methane gas. We can also get gases that are generated from the naturally occurring strata. So particular types of rock will give us our radon gas. So that's why you see radon in some areas and not in others. So that we would classify the naturally occurring phenomenon as a greenfield site. The right-hand slide that you can see there, man-made, so pretty much it's any site where, as an example, we have had an industrial process going on it. So if we've had an old factory going on there, it may have been a contaminated land site when we started off. There may have been gases there, and we've added to those by having perhaps an automotive manufacturing process on a particular site where we've spilt oil or we've spilt chemicals into the strata below. We've had a breach of the slab, and we've added to that contamination. So that's our brownfield site. We could, in theory, if you really wanted to, convert that building into something very nice. So we can actually have our slab here, and we could then put a void former on top of that to give us a void, and then introduce another slab and introduce perimeter venting and do a building conversion on it. I would probably say that we'd knock it down and put a far more up-to-date, more thermally efficient building in its place. So naturally occurring greenfield, man-made brownfield sites. Okay, so we normally come across a typical range of gases and contaminants. So methane, CO2, and radon are the main three that we talk about pretty much on a daily basis. We have another range of contaminants, VOCs, and hydrocarbons. The point about the smoke is that you can't actually see them or smell them until they're in a particular concentration. Usually if you're seeing them or smelling them, then there is quite a severe issue that you would have to deal with. So again, always good to do a site investigation of some particular sort. We're talking about risk analysis in this particular scenario. So the source is where the nasties are. The receptor is us or livestock contained within our building. And the pathway enables the source to migrate to the receptor. So there is an element of risk in there. So we're talking about passive intervention here, pathway intervention, a passive gas protection system. So if we remove the pathway, obviously we're removing the element of risk. It's stopping the source from migrating its way to the receptor. With the site investigation that we considered earlier for expansive soils, obviously we would consider a similar sort of thing for contaminated land. So we do a contaminated land survey, we'd go to site, we'd put in some boreholes, usually 6, over a period of time. The period of time should be long enough to take into account changes in atmospherical pressure and also changes in perhaps the water table, weather conditions, that sort of thing. So we're getting an accurate reading. What we want to do is to install our borehole. We want to get past that initial flush of contaminant. We want to have a settled reading which will tell us what contaminant is there, in what concentration it is present, and the flow rate litres per hour it's coming out of the ground. From that, you can then adopt a gas screening value calculation, which will put the site into a level of severity from 1 being the least severe to 6 being the most severe. This is an example of a conceptual model, which is just showing us the principle between the sources, the pathway, and the receptors. So landfill is going to be our source in this particular example. We have an elevated water table, and we also have permeable strata that is enabling the migration of the nasty through that medium into our receptors, which is our people living in houses with or without basements. We will also have the example here of the petrol station. So a petrol station can be either a receptor, so subject to the contamination from the landfill as we've outlined previously, or it can be a source. So there are a lot of petrol stations that are being decommissioned, structures being taken down, and obviously there is historical ingress of usually hydrocarbons from the tanks that are contained within the strata. And if we're looking to introduce a polystyrene into the build, or we're looking to introduce a new build, we should consider perhaps introducing a hydrocarbon barrier and combination gas membrane, or that in conjunction with polystyrene to protect the polystyrene, especially if we're using that in the foundations. So yeah, a couple of examples there from our conceptual model. So again, very similar to the clay soil, we can actually remove the contaminated strata. This is usually done to a depth of around about 600 mil, and fresh strata is imported. Not quite as severe as our example in the expansive clay soil. So what does that mean? Well, okay, you can probably go out in your garden and cut your grass. You can plant flowers in that particular strata that's imported. You might not be able to plant produce and actually eat the produce from that particular area. So it does have its limitations. We can again remediate the soil, so you can clean it. You can introduce chemicals to actually clean the soil, to get rid of the nasties that are in it. Bit of a double-edged sword. You may well be introducing bacteria into the actual soil itself, so you might be making it worse rather than better, but it does work. If we look down at what we did at the Olympic Park when the Olympics were in full swing down there, we obviously had large landscaped areas and we had areas with structures on them. So in that particular instance, they did do source removal and reintroduction of clean strata. They remediated some of the strata that was down there, and we also used the pathway intervention type of system, our passive gas venting underneath the actual structures that were introduced. So there's basically 3 simple elements we should consider when we are looking to introduce this type of system. So first one is we have our maintained clear void underneath the footprint of the actual building itself. So what we are looking to achieve there is dilution and dispersal of contaminants gases out to atmosphere. So basically what happens is the gas will migrate its way up into the achievable maintained clear void underneath the footprint of the slab. It will be mixed with the tidal air, and then the wind basically will just blow it out and migrate out from the perimeter of the building out into atmosphere. We're looking for 1 complete volume change of air every 24 hours underneath the footprint of the building. So that's the first element of it. The second element of it would be the introduction of our gas membrane or a hydrocarbon barrier or a combination of the two. And that is to form a permanent impermeable barrier across the entire footprint of the building, going across the cavity and terminating at the external leaf on the envelope of the actual building, where it can be trimmed and visually inspected. Any penetrations that are coming up through the slab, so if you've got something like this, for example, it's going to come up through our slabbed area, that should be adequately sealed to provide a gas-tight seal through any penetrations coming up through there. And the last little bit is ventilating at the perimeter. So it's always good to ventilate on all 4 sides of the building where practicable. If you can't do that, you should ventilate on 2 of the longest sides and introduce a cross-flow ventilation type of scenario. And there are various different venting mediums that we will look at moving forward, which will accommodate various different types of structure at the perimeter envelope of our particular building. Lots of industry guidance documents, more so than for our ground movement. These are all pretty much contaminants or application specific. Some of them are up to date, some of them not so up to date, but they are out there for your reference. The main set of guidance documents that people tend to refer to, there are 2 types. So we have the NHBC report, or we have BS 8485, which is the code of practice for design for protective measures for methane, CO2, ground gases, hydrocarbons for new buildings. That's a far more all-encompassing document and will encompass a much wider range of building construction and building type. So NHBC operate on a traffic light system. Green, nothing required. Amber 1, low level, so provision of a void and perhaps a taped membrane. Amber 2, an elevated level of risk, again, provision of a void in conjunction with a membrane, perhaps welded joints on that one. Red, you should consider actively ventilating underneath the footprint of your building. In either scenarios where you introduce a membrane, there are 2 ways of introducing a membrane. You can either use a competent person, so that is somebody that's done it before, or you can use a specialist installer. They're usually somebody that is a specialist installer educated to NVQ level 2 in gas membrane installation. In either scenario, the installation has to be validated by a separate validation company. The number of visits required to a specialist installer are less than to a competent person by the validation company. BS 8485 just looks at different building types, so they are categorized from A to D. They will encompass all types from a private house right the way through to an industrial building. You can see the CS score down the side there from 1 to 6 in the left-hand column, so that gives you the severity of the site, and it gives you the type of building and the point score that is required to adequately protect that building and keep that in terms of guidance. So there are always 3 main criteria that you look at. The floor, scoring you from 0 to 2.5 points. The membranes, scoring you 2 points. And underneath the membranes, the provision of your ventilated area. So that will score you from 0.5 point to 4 points, depending on what it is. Vent form, which is one of our products, will provide 1.5 points and give a guidance score of good. It will also provide 2 points and give a guidance score of very good, depending on the footprint size of the building and the CS classification. So basically, you would tot up your point score there from your slab, your ventilation and your membranes to actually see if you've got enough points there to satisfy the point score that was given on the previous slide for your CS situation and your building type. So there's a couple of different venting components here. So basically we have vent form panels, which are 1.2 by 1.2. The vent form square leg panel that you see on the left there is for ground bearing slabs and suspended slabs. It has 2 different depths, either 100 mil or 80 mil, and it will accommodate a range of loads from 20 kilonewtons per square meter to 50 kilonewtons per square meter. It has a square leg as opposed to the panel on the right hand side, which is again 1.2 by 1.2 meters. Both panels are molded. The cylindrical leg panel will dilute and disperse higher volumes of gas. The cylindrical leg panel only comes in two depths, 150 and 200 mil, and will only accommodate two loadings, 9 or 13 kilonewtons per square metre. The reason for that is it's only to be used with a cast in situ suspended slab. Okay. We also have this product, which you may or may not be familiar with. This is, again, a combination product, and this will accommodate ground movement, and it will also accommodate dilution and dispersal of ground gases. So we have the lower leg of the cell core as part of the anti-heave product. And on top of that is our primary board, which you can just see has holes in it. That allows the gases and contaminants to migrate up into this area, which replicates what our vent form panel does in terms of dilution and dispersal to atmosphere. This comes on the 8x4 module, or 1.2 by 2.4, to keep it in line with the cell core. Vent form does have its limitations in terms of building size and CS situation. Obviously, if you have a CS4, which is quite rare, and a large building, so larger than 15 meters along its longest side, then you should consider actively venting. These tables are all present on the website, and they will give you the particular depth and performance of the product for the particular gas characteristic situation. We have various different venting outlets and accessories. Again, on the website, we have a very comprehensive accessories data sheet, which will give you all the pipes and connectors and the dimensions contained within there for them. Two of the most widely used ones are these. So we have a combination air brick with a periscope vent, usually sited at 2 meter centers around the perimeter of the building, standard envelope of building, brickwork outer, blockwork inner. If you can't do that and you want to put stuff in the floor, then we either have a ground gas vent box, which has two entry-exit points. So you have one on the side there for contaminant up to atmosphere, and one on the bottom for rainwater down to pick up your drainage. Or we have either a rectangular or circular gully vent that has a combination entry-exit point, so it just uses the one for rainwater down. We have a T-piece that we introduce on the side for gas or contaminant up to atmosphere. A couple of different finishes on the lids: brush finish, stainless steel or galvanized, slotted or perforated, depending upon how much gas you want to get rid of. Usually at 5 to 6 meter centers around the perimeter. And then we have the gas bollards that you can see at the bottom there for remote ventilating. We do them in either a high density plastic material, which is the black one. The grey one is a grey primed one, which will be suitable for painting. And we also do a brush finish stainless steel one. With any of these things, obviously, we like to talk to clients on a project-by-project basis to actually see what is required in terms of venting at the perimeter. It may be that there is a combination of products that are required, and we can offer a calculation to give you the number of venting outlets required, and indeed their positioning in terms of their relationships between internal and external corners and straight runs of the building. So all that is available to you. Membranes. This is a hideous slide. I hate it, and I do apologize. There are essentially two different types of installation of membranes. If it's flat, it's loose laid and it's either taped or welded. If it's vertical, it's adhesive backed and applied with a primer. If it is to accommodate sand or cement to stand perhaps a transecting wall on, or some sort of other structure, then it's usually patterned. We have Cordec Puriflex, which will do methane, radon and CO2 and a range of hydrocarbons. And we have Cordec Trigas, which will do methane, radon, CO2 only. And we have a standalone radon membrane. Radon membrane and the Cordec Trigas, they are both taped at the joints. The Cordec Trigas, you can hot air weld that if required. The Cordec Puriflex combination hydrocarbon barrier and gas membrane, that is a weldable only barrier, simply because there is no hydrocarbon resistant tape on the marketplace. So we always have to weld those joints on that particular product. We do have software modeling on the website. So this will give you the heads up if you have a particular contaminant that you have on your site in the strata and you want to know will Puriflex guard against it, and what sort of permeation rates will Puriflex allow the contaminant to come through. So you go on the website, register who you are, what the project is, what the contaminant is, put the information in, and it will give you the suitability of the membrane. It kind of gives you a heads up to actually specifying the membrane, so you know you've got the right membrane for the right contaminant prior to it actually going out to tender and being picked up by the contractor. This just shows you the relationship between HDPE and Puriflex. So HDPE is essentially polythene, reconstituted product, and it lets a whole lot more through than Puriflex does. Also, not particularly suitable for hydrocarbons because, as I say, we can't tape it. So I think the point about the slide is always go for the correct product in the correct application. So in this instance, Puriflex. Right, the last little bit, and this really is just a little overview of structural fill using our Philcore EPS range of products. At Cordec, we manufacture construction-grade expanded polystyrene. So it is essentially styrene monomer that has been relaxed with hot pentane and steam and forced into a block mold or a sheet mold. And when you look at it, you see lots of little beads all pressed together. So it's got good structural properties and some inherent insulation properties. Other products in the marketplace, such as Kingspan, Celotex, Yellow Foam, are extruded products. They are called XPS products. It's a different manufacturing process. They have a better insulative performance than EPS, but not quite so good structural properties. We have a range of products. We work on a 1% compression figure. So what that means is under the given load, the product will compress by 1% of its overall thickness. We have various different load calculations that we can do for you in terms of showing how the product behaves under a UDL or under a point load or under a linear load. We also know the product's density in kilograms per cubic meter. That will assist you with determining the size of sheets or blocks to make them easily manually handleable and getting them to where they need to go on site. And we also have the thermal conductivity value, watts per meter Kelvin. That is physically what the product is. It is not the U value. In terms of establishing the U value, the thermal performance for a particular area, we would again go on slab thickness, perimeter, area, target performance figure, and then we would be able to specify the depth of product. And we also have the range of concrete that each product will accept. So that's our depth in millimeters of concrete. If any of you would like a CPD on lightweight fill, I can certainly bring some of the samples that are in my shed and leave them at your practice, which will free up room in my shed because I've got lots of them there. Happy days. Right, so a couple of examples. Quite a small project, Kia Oval, Peter May stand. This was basically a weight saving exercise. So what you can see there at ground level actually isn't ground level. Underneath this particular area here, this concrete slab, there are other voids underneath it. And so the engineers wanted to reduce the amount of additional weight that was being imported onto that particular slab. So we built up the terracing using our Philcore EPS, and then they poured the concrete over the top of it to form the actual terraces and put the seating on. So in this particular application, we considered the two design examples. So what was the wet weight of the concrete? How was that going to impose load onto the actual polystyrene? And after the concrete had gone off, how is it sitting on top of the concrete and what loads might be transferred down through it, through either the feet of the actual seating arrangements that were being put on there, or indeed the seats in combination with people sitting on them. Polystyrene is never going to be as cheap as dirt, and you can have a win-win situation with it because you are saving weight on load-sensitive surrounding structures. You are saving on transportation because you can get a lot of polystyrene into very few vehicles and get it to where it needs to go. You have the thermal performance side of it. So if you need to produce a particular U value just using fill core, it's there. It can be cut and shaped and profiled to accommodate a particular structure on site, whereas conventional fill can't. So it is a very sort of flexible, accommodating product. This is right at the other end of the scale. So this was London Bridge Station redevelopment, a very large project, 7,500 cubic meters of polystyrene, 17,000 square meters of Puraflex. This was a live railway station that was sitting on, I think they were either Edwardian or Victorian brick arches, so they were quite load sensitive, and they wanted to raise up the actual deck of the station itself to provide a new station concourse to an additional height. So they're raising it up by an additional height of 3.5 to 4 meters. The station was kept open. 122,000 people a day going through it. So they worked on one half while they kept the other half open. So you can see here we have a model of the actual blocks and sheets that were required. So we were optimizing the amount of blocks that we could supply to give an optimum block layout and minimize wastage. There were several different densities of material to accommodate both loads from the railway engines and what have you, rolling backwards and forwards over areas where they were sited on the track. In other areas where it was just a track makeup, there was a slightly less dense load, less dense material for a lighter load. And in areas where we had void former required for just simply blocking up holes underneath stair cores. Again, one of our lightest products introduced there. All of this was done in conjunction with Puraflex, which was all welded by a specialist on site, because obviously we had historical instances of ingress of heavy locomotive oil on site, and we also wanted to protect against future spills. So most of this was loose laid horizontally, some of it was adhesive backed and installed vertically, and the rest of it was actually wrapped. So you can actually wrap individual blocks or collections of blocks of Puraflex, fill core with our Puraflex hydrocarbon barrier. We do have a full project support service down at Cordec. We have two departments. One looks at standard products and the other looks at bespoke products. And we can walk you or your clients through the whole design sort of guidance procedure, offering advice on coatings, loadings, finishes, dimensions, all that sort of stuff. We have CAD/CAM facilities down at Cordec in Slimfold, where we can do 5-axis CNC controlled routing. So as well as cutting the block using hot wire cutters in 3-axis or 5-axis methods, we can mold it and we can also route it. We have the technical library on the website. We have a product range on the website, and we also have our BIM library. So we're members of the National BIM Library. If you have a particular application that you can't see on the website, do by all means please give us a call. We are quite happy to have a look at what your proposals are and perhaps draw up a bespoke sectional detail for you to accommodate those. So everything's doable. Thank you very much for listening this morning. My name's Simon, and I am part of the technical advice team. I'm here to offer help writing specifications should you need it, assistance with non-standard requirements, also quite happy to go and visit the site. I'm part of the technical support team. Half of us guys are out on the road and half of us guys are based down at Slimfold. So I will hand you back over to Shaneka. If there are any questions, happy to answer them now or put them in a chat box, or do by all means send us an email, and happy to assist. Thank you very much indeed for your time this morning.
Thank you, Simon, for the lovely webinar. We do have 3 questions. Oh, we have 4 now. I'll only answer a few because we have run over a little bit.
Okay.
So we'll do the first two. So if ground heaves and fills are void below a B&B floor, for example, can it be then expanded further? Say at another time, this is rendering the void former redundant.
So if it's filling in below a block and beam floor,
Yes. Yeah.
we would not put a void former underneath a block and beam floor. So your block and beam floor, the void is formed just by the presence of the block and beam floor spanning from one side of the perimeter foundation to the other. So we would never introduce a compressible polystyrene void former in there. The instance where we introducing the compressible polystyrene void former into a cast in situ suspended slab, yes, it does get rendered as finished with, because basically the cell court is only there to protect the concrete whilst it goes off and maintains full strength. So after heaves occurred, yeah, the void former still sits in there, but it's not actually doing anything.
Thank you. So when using heave precaution clay master on a trench foundation due to a tree in close proximity, why does it need to be applied on the inside of the face footing, and why does it need to start 500 millimeters from the bottom of the trench?
Okay, so it needs to be applied on the inside face of the perimeter of the foundation, because you are parceling off a section of strata, and should that strata heave, you have to have some sort of medium on the inside face to accommodate that movement from the strata within. You don't put it on the outside, because that is basically the global expansion area. So if heave occurs there, then it will just migrate along the face of the foundation and dissipate out into the global area. We start it 500 mil above the base of the foundation, because you have to have an anchor point. So the anchor point is deemed to be in the area of strata not to heave. And you need the anchor point, because if you extended the clay master in this example all the way down the inside face of the foundation, if heave occurred, you could actually move the foundation over. So hence that's why you have the 500 mil.
Thank you. So I've had a few comments from Brandon and Ian that say thank you for the webinar. That is very interesting. I do have a few more questions, so I'll send that to you later, and I'll wrap up the webinar. So if there's anyone that has viewed today's webinar and think it will be a benefit to a colleague, we'll be uploading the webinar to our YouTube channel. If you've got any feedback on webinars or any sessions you would like to see us cover, any specific topics, regulations, or any industry related, then you think would be a good 40 to 50-minute presentation, please get in touch. Alternatively, if you think that you yourself could present one of our webinars, please let us know. We'll love to have you on board. And with that, I'll wrap it up. Thank you again, Simon, for your time, and hopefully we see you all next month.
Fantastic. Thanks very much, Shaneka. Thank you very much.